So we have this problem here. We're given ABC is a right angle. That's all we're given. And we need to prove that ABD, this first part of the right angle, is comp to this second part of the right angle, CBD. Right? We need to say that they're comp. So we start by writing our T-chart, statements, and reasons. We say number one, we write down our given, ABC is right angle. It's going to be given. Okay, so where do we go from here? Well, what do we have available? Do we have any theorems or definitions that start with right angles? Yeah, we do, right? We have the definition of right angles. So we can go ahead, if we're given it's a right angle, then we can go to equation saying that the angle measure is equal to 90 degrees. So why don't we go ahead and start with that? So we'll say measure angle ABC is equal to 90, and that's going to be def of right angle. Okay, now what do? Right, we turned our given into equation. There's nothing left. So we're now going to look at our figure. And if you look at the figure, we have two adjacent angles. When you see this, two adjacent angles, your mind should immediately jump to angle add pos. And what does angle add pos let us say? It lets us say if we have two adjacent angles, we could say first part of the angle plus second part of the angle equals the whole angle. So that's what we're going to do. We're going to use that to create an equation using the figure and angle add pos. So how does this work? It's ABD, measure angle ABD, that's the first part of the angle, plus measure angle DBC, that's the second part of the angle, is equal to ABC, the entire angle. So it's going to go measure angle ABD plus measure angle CBD is equal to measure angle ABC, and then that's going to be angle add pos. Okay, so we have our equation, right? Well, we have our two equations, and that's all we have, right? Normally we have 3, maybe 4 equations, but here we only have 2 equations. So what's the next step? It's substitution. So what can we substitute where? Well, there's not much choice, okay? What we're going to do is we're going to take this 90, and we could substitute him anywhere we see measure angle ABC. And in another equation, right? That's something that students always get confused on. It's like, okay, well, then I'm going to take the 90 and put them right here in the same equation, and I'm going to have an equation that says 90 equals 90. No, you want to substitute into an equation, a different equation. Okay, so where do I see do I see ABC here in this second equation? Well, it's hard to see because my handwriting and it got squished and everything, but that there is a measure angle ABC. Right? So I'm going to go ahead and take that 90 and I'm going to substitute them right in there. So that's step 4 is measure angle ABD plus measure angle CBD is equal to 90. All right, great. Right? Where can we go from here? Where can we go? Right? Well, now we can go ahead to definition of complementary angles. Right? Definition of complementary angles lets you say if two angles comp. Right, you have a statement that says two angles comp, then you can go ahead and create the equation. But remember, definitions go both ways. They're if and only if. They go both ways. Right? You can say statement to equation, but you could also go equation back to statement. So we have this equation. We're going to go back to the statement. Okay. So I'm going to go over here, and I'm going to go and say, 4 is substitution. And then so we're going 5. We're going from equation to statement. And the statement is angle ABD and angle CBD comp. Reason, definition, comp. Or definition of complementary angles, right? Whatever it is. I'm writing this for short because I'm kind of in a rush, and also I don't have space. So, anyways, definition of complementary angles lets us go from equation to statement. Right? It also lets us go from statement to equation, but in this case, we're going from equation to statement. Now, what do we want to do? Oh, no, that's our proof statement. That's our proof. We're done.